Hello friends, welcome back to my channel once again. In the last video we have seen about the simple cubic crystal structure and its packing fraction, effective number of atoms and how many number of the coordination number means whatever may be the atoms, nearest atoms bonded to that corresponding atom, it is called coordination number. So, we have seen these three concepts as well as those three things, and especially the packing fraction, how to find the packing fraction or packing efficiency, and we have found for the simple cubic. If you want, we can see the previous slide here. Yes, for simple cubic we got this answer, that is 52%, and it means that the 52% part of that particular simple cubic unit cell has been filled with the atom, and remaining 48% part is empty or void space. Okay, right. Now, today the next structure, that is body centered cubic, we have to find the same packing fraction for this body centered cubic unit cell. Now, first of all we have to understand how atoms are arranged in body centered cubic crystal structure or unit cell. So, we know that body centered, in the beginning only, in the very first video we have seen. So, body centered 8 atoms are present at 8 corners, and along with that one additional atom, complete atom, is present at the body centered position. Body centered position means at the center of that unit cell. So, that atom is completely present in that unit cell. Okay. So, you can see this is what the structure of body centered cubic crystal structure or body centered BCC unit cell. We will call it just it as unit cell instead of crystal structure. So, obviously these unit cell repeatedly creates the crystal, right. Now, this is what the body centered unit cell, BCC cubic unit cell. So, here you can see these corner atoms. I yesterday told you the whole corner atom is not completely present in one unit cell. It is shared by 8 different unit cell. That means, in one unit cell 1/8 part of that atom is present. So, here also this particular portion is the 1/8 part. Now, you can see this portion is 1/8 part, this portion is 1/8 part of this corner atom, this portion is 1/8 part of that particular corner atom. Likewise, this corner atom is shared by 8 different unit cell. Now, we are talking about this particular unit cell, and therefore, how much part of this particular corner atom is present in this unit cell? Only 1/8 part, and yes, diagrammatically it is like this. Okay. Now, and this body centered atom is completely present in that unit cell, body centered cubic unit cell. Okay. So, first of all we will see how many number of atoms are present in this unit cell, because we know to find the packing efficiency we must know the effective number of atoms. So, how to find the effective number of atoms? So, here just if we go to the next slide, effective number of atoms, right. So, here we can see effective number of atoms, since 8 corner are occupied by 8 atoms. So, therefore, I have written here 8, and each corner atom is shared by how many unit cells? 8 different unit cells. Therefore, we should divide it by 8, or in other words we can say that corner atom or in this particular unit cell, how much part of that atom is present? 1/8 part. That is why, and likewise how many atoms we have? 8 atoms. Therefore, 8 multiplied by 1/8, since 1/8 part of that atom is only present in this particular unit cell, and plus 1. Why plus 1? Because one atom, this center atom is completely present in that unit cell. Therefore, there is no any sharing of that atom with neighboring unit cell. Therefore, that one will be added as it is. So, 8 into 1/8, again 1. So, 1 plus 1, 2. So, in case of BCC unit cell, we have effective number of atoms 2. That means, the total number of atoms present in the BCC unit cell are 2. As we have seen in case of simple cubic, it is only 1, right. Okay. Let us go to the diagram again. Next, we have to find the relation between A and R. What is A? Lattice parameter. What is R? R is the radius of our atom. So, to find that, just let us talk about this particular diagram. What I have taken here, simply the body diagonal. This is what a body diagonal along, because one atom is present at the body centered point, and that is why, as we have considered in case of simple cubic structure, we cannot take only one face We cannot take into consideration only one face, as we have seen. See, in case of simple cubic structure, we have taken only one face, because this is true from any faces. If we look from top, bottom, or all 6 faces, you will look this type of structure when you are dealing with simple crystal or simple cubic unit cell. But in body centered unit cell, one atom is present at the body centered position, and that is why we cannot ignore that, or we cannot take simply one face side. So therefore, we have to talk, or we have to see about the body diagonal. This is what body diagonal. This is not the diagonal of one face. This is body diagonal, right? Or in short, we can say it is a cubic structure. That is why it is a diagonal of a cube, body diagonal of a cube, right. So this A is the side, that is what our lattice parameter, small r is capital R is what our radius of atom. Now this body diagonal, by looking at the diagram only, you can say that body diagonal is nothing but this R plus this 2R. Why 2R? Because this complete atom is present in the body unit cell, and 2R means its diameter, and then the R of this particular corner atom. So that means this body diagonal is equal to how much? 4R. R plus 2R plus R. How much? It is 4R. And how much is the diagonal, body diagonal of a cube? It is root 3A. It is root 3A. How it is? If you want to calculate, now just look at this particular triangle, because if I consider this bottom face, if I consider the bottom face, and bottom face diagram will be like this, or if I join these two corners, let us take the brush. So what I am saying, okay, I will draw here from this point. If I join this particular diagonal, if I join these two particular points, that diagonal is nothing but the diagonal of a face, which is the bottom face, and it is what? A square. What is the square's diagonal? It is root 2A, that is root 2A. Okay, now this is root 2A, and now consider this triangle. Let us consider this triangle. Let us consider this triangle. Here, that is what we have written here. This lower side is root 2A. This is the side, that means what? Our lattice parameter. Now this is root 2A. This is A. So again, by the Pythagoras theorem, because this is also a right angle triangle, and therefore this is root 3A. So what is that root 3A? It is body diagonal. Root 3A is body diagonal, or we can say the cube diagonal is root 3A. If we talk about the square of side A, its diagonal will be root 2A, and if we talk about the diagonal of a cube whose side is A, then it is root 3A. So this body diagonal is root 3A by our side A, since our side is A, and that is what, in terms of our radius of atom, it is 4R. So simply we can write root 3A is equal to 4R. Yes, root 3A is equal to 4R. In case of simple cubics, directly we have seen from the diagram 2R is equal to A, but here little bit extra things are there, because we have to talk about the body diagonal. Therefore root 3A is equal to 4R, right. Now this relation also we got. Next, yes, so root 3 is equal, 3A is equal to 4R, therefore A is equal to, just bring this root 3 to that side, 4 divided by root 3R, because we have to replace A at the final when we are talking about packing efficiency. And effective number of atoms we have already found. Now go to the packing fraction. So packing fraction, we know simply it is volume of atoms divided by volume of unit cell, but volume of one atom multiplied by the effective number of atom, that will give you the total volume of that atoms present in that particular unit cell, right. So therefore N effective into V atom divided by V cell, V for volume, N effective for effective number of atoms. So effective number of atoms, substitute there 2, volume of one atom, because atom's radius is R and it is spherical in nature, that is why it is 4 by 3 pi r cube. Everybody know the volume of sphere, and volume of cell in the denominator, because cell is cubic in structure there, and whose side is A, therefore A cube. Okay, good. Now next step, this 4 multiplied by 2, yes 8, and this 3 as it is 8 by 3 pi r cube in the numerator as it is. In the denominator, instead of A, what we have to substitute? A is equal to 4 by root 3 into R. So substitute here 4R divided by root 3, it is a cube because A cube, and then do the calculations. 8 as it is, pi as it is, okay, r cube as it is, in the denominator this 3 as it is, cube of 4 is 64, cube of r is r cube, and in the denominator we have root 3 and its cube, root 3 and its cube. So, root 3 cube means 3 times, right, root 3 into root 3 into root 3. So, 2 root 3 we can multiply together and we can get it as 3. So, root 3 cube we can write it as 3 into root 3, 3 into root 3, that is what, but it is in the denominator of denominator, that is why it goes to the numerator. Therefore, it is coming here at the numerator 3 root 3. Remember, root 3 its cube, that means root 3 into root 3 into root 3, and therefore, it is 3 root 3. Okay. Now, finally, this 3 and this 3 can be cancelled. 8 is 864, this r cube get cancelled, and what remains only this root 3 and pi in the numerator, and 8 is 64, that is 8 in the denominator. So, what we got? Root 3 pi by 8. Okay. So, root 3 it is 1.73. Now, substitute the value of pi 3.14 divided by 8 as it is. If we multiply and divide by 8, finally, we get 0.679. You can check the calculations, 0.679. So, approximately we can write 0.68, right, and in terms of percentage it is 68%. In terms of percentage it is 68%. Right. So, what is that 68%? It is packing efficiency of our BCC unit cell, body centered cubic unit cell. So, by looking at the diagram only or by just simply observing the BCC structure, we can say its packing fraction must be greater than simple cubic. Why? Because in simple cubic 8 atoms are present at the 8 corners only. But in case of body centered cubic, along with the 8 atoms at 8 corners, 1 atom is present at the body centered point. That means more volume has been filled with the atoms, and that is what we are talking about packing efficiency. How much is the volume of that particular unit cell is filled with atoms, and one complete atom is present in the unit cell, that means the packing efficiency has to be increased, and it has been increased. Yes or no? Yes. If we talk about the simple cubic, it is 52%, and now we got for the body centered cubic it is 68%. Okay. So, 68% is the packing fraction. So, how much is the void space? Remaining 32. Remaining 32% is what? Void space, or we can call it as empty space, right. Okay. This is about body centered cubic unit cell. Now, we can go to the next, that is face centered cubic, FCC, face centered cubic unit cell. Again, we have to talk about the unit cell. In case of face centered, along with 8 atoms at 8 corners, extra 6 atoms are present at 6 faces. Yes, that is why it is called as face centered cubic. Means at the center of every face we have one more additional atom along with 8 corner atoms. So, now we know that corner atoms has been shared by 8 different unit cell. Similarly, if I want to talk about the face centered atom, so what happens to the face centered atom? Face centered atom is not completely present in that unit cell as like the body centered atom. Yes, so it has been shared. So, it has been shared with how many different unit cell? Now, again we can take the yesterday's example only. Here we have taken in the last video we have taken the example of football. If I want to construct a building such that, and I want to keep a football or volleyball at the corner of my room such that the center of football should coincide with the center of that corner. Now, similarly, if I want to put that football at the wall or in the window, let us consider, you can see one window behind me. So, if I want to put the volleyball or football at that window, so we have to keep such that part of that particular window, or we can say the plane of the window should cut the diameter. Plane of the window should cut the diameter. So, that means what? That particular football is not completely present in my room, right? Half part of the football is present in my room and half part of the football is present in that particular back room. Are you getting? So, in short we can say the face centered atom is shared by how many different rooms? 2 rooms, that means 2 different unit cell. That means that football, when you have to kept in the window such that the plane of that particular window should cut the diameter. So, then that football is shared by 2 different rooms. So, similarly, when we are talking about a face center atom, that face center atom is shared by 2 different unit cells, right. Now, so likewise, how many faces we have? We have 6 faces, right, 4 side faces and top and bottom. So, how many faces to the cube? 6 faces. 6 faces, 6 atoms, but not 6 atoms are present in one unit cell. All those 6 atoms which are kept at the center of every face has been shared by 2 different unit cell, and as usual our corner atoms are shared by 8 different unit cell. So, that is why first of all we will find how many number of atoms, that is what the effective number of atoms present in our face centered cubic unit cell. So, this is as usual 8 into 1 by 8, 8 number of atoms present at 8 corner, and each atom is shared by 8 different unit cell, therefore 1 by 8 plus 6 faces are there. At the 6 faces we have 6 atoms, but each and every atom, face centered atom is shared by 2 different unit cell, that is why 1 by 2. It is now see here, these atoms, a corner atom is shared by 8 unit cell, that is why 1 by 8. These face atom are shared by 2 unit cell, that is why 1 by 2, right, and then that is equal to 8 into 1 by 8, 1, and 6 into 1 by 2, that is 3. So, in total we have 4 different, or sorry, in total net atoms present in that particular face centered cubic unit cell are how much? 4. So, the effective number of atoms also increasing when we are moving from simple cubic to body centered to face centered, and yes, from this only you can guess the packing efficiency or packing fraction has to be increased. Yes, okay. And next what we have to find the relation between A and R. So, see this now here, because atom is not present at the body center point, okay, corner atoms are there, and at every face we have one atom. Now, look at this structure, this is what the structure of face centered cubic. See, these are the corner atoms, and this atom is face centered atom, but this atom you can see it looks only the half portion, because half portion is shared by this side unit cell. Similarly, this one is the face center atom which is only looking half, because half is shared by its neighboring unit cell. Okay. Now, if I talk about this face or this face, just see this face here, this face we want to find the relation between A and R. So, now these are the 3 atoms involved in this face. This R is a corner atom, for a corner atom, this 2R is for the face center atom, and this R is for this corner atom. R is what? Radius of your atoms. And again, now this cubic cell is also having lattice parameter or the cube of side A. So, this side is A and this side is also A, because it is cube. Now, this is A and this is a right angle triangle. So, this is what? The hypotenuse of right angle triangle, and it is root 2a. Yes or no? It is root 2a. So, root 2a, and that is nothing but r plus 2r plus r, that means 4r is equal to root 2a. 4r is equal to root 2a. This is what the relation between a and r. What is a? Lattice parameter or side of cube, and r is radius of atom. So, this is what the relation root 2a is equal to 4r. What we have to replace? We have to replace a in the denominator. That is why we can take this as a is equal to 4r divided by root 2. A is equal to 4r divided by root 2. Yes, this is what relation we want, and number of atoms, effective number of atoms, and this is the relation between a and r. Now, we can go to the PF, that is packing fraction. Okay. Again, packing fraction, volume of total atoms divided by the volume of unit cell, but volume of total atoms means how many number of atoms present into the volume of one atom. So, how many number of atoms are present? That are the effective number of atoms, and volume of one atom divided by volume of cell. How many number of atoms are present in face centered cubic? 4, substitute here. Again, volume of one atom, 4 by 3 pi r cube, spherical atom whose radius is capital R, and volume of unit cell is a cube, because it is a cubical structure of side A, that is why A cube, right. Now again do the calculation. In the numerator 4 into 4 16, 3 in the denominator as it is, pi as it is, r cube as it is. We have to substitute this A as 4 by root 2 r, 4 by root 2 r, and its cube. Okay, go to the next step. 16 as it is, pi as it is, r cube, in the denominator 3 as it is, 4's cube is 64, r's cube is r cube, and root 2, it is in the denominator of denominator, and root 2 cube again similarly root 2 into root 2 into root 2. So, root 2 into root 2 we can take 2, so it is 2 root 2, root 2's cube is 2 root 2, but it is in the denominator of denominator, and that is why it goes to the numerator 2 root 2. Okay. Again 16, we can take 16 into 2 32, and 32 to the 64, and in the denominator 2 into 3 6. So, in the numerator it remains only root 2. So, root 2 by 6, r cube get cancelled, and pi is in the numerator. These calculations are very simple, you can do, right. So, finally what we get, root 2 by 6 pi. So, substitute the values, root 2 1.414, pi 3.14, in the denominator 6 as it is. If we do this calculation, if we multiply these two numbers and divide it by 6, what we get is 0.740 something, but we will consider only 3 digits, 0.740, and in terms of percentage it is 74%. It is 74%. So, what we got, for the face centered cubic unit cell, the packing efficiency has been increased than simple cubic or than body centered cubic, and it is 74%, obviously because effective number of atoms has been increased, right. So, 74% is the packing efficiency for face centered cubic. So, how much is the void space remaining? 100 minus this 74, how much? It is 26. So, 26% is the void space or empty space in face centered cubic unit cell. Okay. So, I hope these two concepts are clear to you. If you have any doubt, you can post in the comment box, and remaining things we will see in the next video. And if you really like this video, you can like, share and subscribe to my channel, and press the notification icon, so that you will take, or you can get the notification of my next video. Till then, we will meet in the next video. Thank you.